Certainly. Here is your text punctuated. We should tune the telescope into worlds being conceived, and gracious, my golly, who requested this? We're tracking down systems in obscurity. Ages, however long, logical request has dug into the beginnings of our universe. The common clarification has been the theory of prehistoric cosmic detonation. Endless studies and the cooperative endeavors of huge numbers of researchers have supported this hypothesis, giving significant proof for how the universe came into being. Anyway, the scene of science today is notably not quite the same as that of the past. Mechanical headways persistently introduce new speculations and viewpoints, testing what we once thought about undeniable insights. In this advancing logical scene, where new revelations reshape how we might interpret the universe, Neil deGrasse Tyson has become an unmistakable voice. Now, a pivotal improvement has become known as the James Webb Space Telescope, which has divulged a disclosure that raises doubt about the well-established theory of prehistoric cosmic detonation. This disclosure includes the recognition of a stunning 750 new worlds, each of which overcomes our past presumption of what worlds ought to be like. By the way, the James Webb Space Telescope was imagined and intended to help us figure out the beginning of systems, so we ought not be astonished that it's driving us to scratch our heads. Go along with us as we investigate how the new pictures from the JWST expose the theory of the universe's origin with the disclosure of 750 new cosmic systems. Researchers have advanced the theory of the universe's origin as the main clarification for the beginning of our immense universe. As per this hypothesis, around quite a while back, the universe appeared through a baffling, inestimable occasion of some kind. It's the definitive birth story of the universe. The astounding idea of the pictures caught by the James Webb Space Telescope has tested researchers' comprehension of the universe's beginnings. The speculation that these pictures straightforwardly go against is the Big Bang Theory, which has for some time been respected as an obvious truth by the greater part of cosmological scholars. These worlds give off an impression of being too little, too smooth, too old, and too various when contrasted with the eye of the Big Bang speculation. The little size of the noticed systems altogether goes against the normal conduct in a growing universe. As indicated by the speculation, as the universe grows, objects ought to seem bigger with increasing distance. As per the theory of the universe's origin, at the earliest reference point of the universe, all matter, energy, and the building blocks of the cosmos were compacted into an extremely minuscule and exceptionally focused point. This point is known as a peculiarity. Inside the peculiarity, all the matter and energy in the universe existed in an exceptionally packed structure. The outrageous thickness infers that a colossal measure of mass and energy was concentrated inside an imperceptibly small space. The temperature inside the peculiarity would surpass any temperature that can be noticed or duplicated in our ongoing comprehension of the universe. The energy stored within this hot, thick point was the seed from which the whole universe would unfurl. Extension, this is the reason the peculiarity denoted the start of the universe as we know it. It was the beginning from which all that in our universe came. After the beginning peculiarity, the universe began the journey of development and expansion. This interaction happened throughout the span of around 13.7 billion years, forming the universe as far as we might be concerned today. The development of the universe began with an exceptional explosion of quick development known as inestimable expansion. During this stage, the universe extended at an unfathomable rate, far surpassing the speed of light. It resembled the texture of space itself was extending and expanding, taking everything inside it. Vast expansion assumed a gigantic part in molding the enormous scope design of the universe. It streamlined anomalies, homogenized the appropriation of matter and energy, and set up for the ensuing development of universes, stars, and other inestimable designs. As the universe kept on growing, the pace of development bit by bit dialed back. However, with this data, it means quite a bit to note that despite the fact that the underlying time of inestimable expansion finished, the universe kept on growing at a quantifiable rate. This continuous development is known as the development of the universe or grandiose development. Researchers have noticed the impacts of this development through different perceptions, like the red shift of light from far-off cosmic systems. The red shift demonstrates that as the universe extends, light waves get extended and shift towards longer frequencies, moving them towards the red finish of the range. We'll dive into the subtleties of this later on in the video. From the beginning, the pictures of the new cosmic systems that were taken by the JWST look totally stunning. Positively, you can see many cosmic systems all in a similar casing, and the sheer power in the photographs is something you just can't disregard. Yet, that is what things resemble to the typical individual. For analysts, things are the inverse. These pictures are astonishing, to say the least. They don't match researchers' thought process they would see in view of their hypotheses. They're seeing far additional systems, in fact, than anticipated, and these cosmic systems are different in a few astonishing ways. They're smooth, more modest than envisioned, and truly old. This multitude of amazements is causing somewhat of a frenzy among the researchers. One paper even begins with the word alarm in its title, so you know things are serious. The worlds seem to be something they should. The age of the noticed cosmic systems is by all accounts unquestionably abnormal. Here, the JWST perceptions demonstrate the presence of universes that give off an impression of being startlingly old. This challenges the normal course of events of cosmic system development and advancement inside the structure of the theory of how things came to be. In addition, there's likewise the way that the overflow of noticed worlds is a ton higher than what the Big Bang theory predicts. A certain dissemination and thickness of systems in view of the development and advancement of the universe are anticipated. However, the JWST pictures show a monstrous number of systems, which raises inquiries regarding the precision of the forecasts made by the speculation. There's additionally the way that the perfection of these systems is completely unforeseen. The theory of prehistoric cosmic detonation suggests that systems ought to display anomaly and varieties in their structures because of the elements of their arrangement and development. Anyway, the JWST pictures uncover worlds that show up curiously smooth, coming up short on the anticipated degree of intricacy and you'd regularly hope to see, as indicated by the Big Bang nucleosynthesis hypothesis. While the extension was occurring, we fundamentally had all the stuff that makes up our universe condensed into an extraordinarily little volume. Obviously, matter proved unable to get by in space like this, so something needed to give. As the universe extended and cooled off, changes occurred. Particles like protons, neutrons, and electrons began to interact with light and energy in their environmental elements. These collaborations assumed a crucial part in molding the arrangement of matter in the universe during the initial couple of moments after the Big Bang. There was an interaction called nucleosynthesis. This interaction included the making of lightweight components like hydrogen and helium. The limit temperatures and energy during this stage took into account the combination of protons and neutrons to frame these straightforward nuclear building blocks. Hydrogen, the least complex and most plentiful component in the universe, was framed fundamentally during this early period. Helium, the second most plentiful component, additionally arose during this time. These components were instrumental in making way for the development of stars, universes, and more intricate components that would come later in the universe's history. The combination of these basic building blocks was a significant achievement in the advancement of the universe from an early-stage ocean of particles and energy. The early universe changed into a state where matter in reality began to come to fruition. This process established the groundwork for the rich variety of matter and the huge, enormous structures that eventually came into being. Currently, the Big Bang scholars themselves expected to notice universes that were mutilated and mixed because of various crashes. Anyway, the JWST pictures present an alternate story. Rather than turbulent and tousled systems, the pictures uncover predominantly smooth circles and efficient twisting structures, looking like the systems we find in the current-day universe. This startling perception challenges the thought that consolidations are a normal cycle in the development of universes, since obviously these new universes haven't gone through any of the difficulties that you'd ordinarily anticipate assuming that you were following the Big Bang hypothesis. On the off chance that there are only a couple or, on the other hand, no consolidations occurring out there, it becomes doubtful for minuscule systems to develop and become many times bigger. This infers that these cosmic systems were never initially minuscule in any case. Alongside it, the optical deception anticipated by the extending universe speculation, where items seem more modest with increasing distance due to development, additionally doesn't exist. As space experts have carefully noticed and planned the universe, they have found a striking example. The bunching of universes and the in general construction of the universe. Cosmic systems tend to assemble together in huge gatherings, bunches, and superclusters, shaping mind-boggling networks that reach out across the universe. This noticed enormous scope structure lines up with the expectations made by the theory of how things came to be. As per the hypothesis, the universe started as an amazingly thick and hot state, and over time it extended and cooled. As the universe extended, gravity played a crucial job in molding the dispersion of matter and the arrangement of universes. The gravitational impacts anticipated by the theory of the universe's origin are reliable with what we notice today. Gravity draws matter together, making worlds bunch in specific locales and forming filamentary structures that interface them. These designs uncover the enormous web-like example of the universe. The presence of these universe groups and the interconnected snare of matter offers solid help for the Big Bang hypothesis. The development of cosmic systems and their appropriation across the universe lines up with the gravitational impacts anticipated from the underlying thick and growing state set by the hypothesis. At the point when you look again at the size of the worlds the James Webb Space Telescope found, you can truly perceive how the pictures depict an entirely different reality than we thought. As per Big Bang scholars, these minuscule cosmic systems develop into the larger universes we notice today through a course of impacts and consolidations. To make it simpler to contemplate this speculative situation, you can contemplate the individual worlds as an assortment of stars and dark matter that are kept together by gravity. In this present circumstance, at the point when two universes come into close contact with each other, their gravitational fields interact with one another and revamp the stars and gas inside the cosmic systems. If the universes, as a matter of fact, impacted, the consolidation would bring about the arrangement of new stars and increment the size of the recently joined world. We call this course of blending cosmic nucleosynthesis. As per the theory of prehistoric cosmic detonation, it is accepted that these little cosmic systems would have gone through various consolidations over billions of years to shape the huge winding and curved systems that we see today. Anyway, the universes noticed by the James Webb Space Telescope, JWST, tested this thought. The universes found by the telescope are shockingly little, smooth, and apparently old, resisting the assumptions set by the theory of the universe's origin. The pictures caught by the JWST uncover a populace of systems that are a lot more modest and smoother than expected, raising inquiries regarding the legitimacy of the current cosmological models. The beginning and development of these systems show up to go against the forecasts made by the theory of the universe's origin, which sets that cosmic systems ought to advance through consolidations and impacts over the long haul, rather than the turbulent and unpredictable structures anticipated from cosmic consolidations. The worlds seen by the JWST show clear-cut, smooth shapes suggestive of present-day universes. This startling revelation challenges our comprehension of how worlds structure and develop inside the system of the Big Bang hypothesis. Besides, the age of these newfound cosmic systems is moreover astounding. The JWST perceptions propose that these cosmic systems formed significantly sooner in astronomical history than previously thought conceivable. This revelation raises major inquiries about the timetable of cosmic system development and the cycles that oversee the advancement of the universe. Researchers are presently grappling with the ramifications of these discoveries and are attempting to modify existing hypotheses to accommodate the new perceptions. The disclosure made by the JWST has opened up new roads of research and has ignited a re-established interest in understanding the early universe and the development of systems. In synopsis, the pictures caught by the James Webb Space Telescope challenge the winning speculations of cosmology, especially the theory of the universe's origin, by uncovering a populace of suddenly little, smooth, and old cosmic systems. These discoveries feature the powerful idea of logical request and the non-stop development of how we might interpret the universe. As researchers dig further into these secrets, they make certain to reveal more astonishments and further refine our vast story. The revelations made by the James Webb Space Telescope, JWST, have touched off a vivacious discussion among cosmologists and astrophysicists as to central hypotheses that govern how we might interpret the universe. One of the most striking parts of the JWST perceptions is the sheer number and variety of worlds it has uncovered. These worlds not just challenge existing models of universe development, yet additionally raise charming inquiries concerning the hidden physical science and processes at play during the early stages of the universe. One of the key puzzles introduced by the JWST discoveries is the idea of world morphology. In contrast to the sporadic and divided universes anticipated by the progressive blending model of world arrangement, the JWST pictures uncover universes with amazingly smooth and requested structures. This startling revelation recommends that elective components, maybe including more continuous and less savage cycles, may have molded these cosmic systems over enormous time. Besides, the age distribution of the cosmic systems saw by JWST represents one more problem. A portion of these systems gives off an impression of being a lot more seasoned than expected, challenging the ordinary timetable of universe development. This disparity infers that our current comprehension of the beginning phases of world development might require huge modification to accommodate these new perceptions. The James Webb Space Telescope's capacity to distinguish and break down worlds at remarkable distances and goals has additionally shed light on the variety of heavenly populations within these systems. By concentrating on the tones and spectra of far-off cosmic systems, cosmologists can gather important data about the age, structure, and star-forming history of these inestimable elements. The JWST perceptions have uncovered a rich woven artwork of star development exercises across various sagas, giving hints to the fundamental cycles driving universe development. Besides, the JWST's infrared abilities have permitted some researchers to test further into the grandiose past than any time in recent memory, disclosing systems that existed when the universe was just a small portion of its ongoing age. These old worlds give a window into the developmental phases of inestimable development and proposition experiences into the conditions that won during the early stages of the universe. In the end, the James Webb Space Telescope has reformed how we might interpret cosmic system development and advancement by testing laid-out speculations and revealing an abundance of new revelations. The perceptions made by the JWST have brought up major issues about the instruments driving universe morphology, the course of events of universe arrangement, and the nature of grandiose advancement itself. As researchers proceed to dissect and decipher these earth-shattering perceptions, we can expect further bits of knowledge that will reshape our astronomical story and develop our comprehension of the universe's beginnings and advancement.